Calculating the general lighting load and the number of circuit breakers involves a few steps. Firstly, you need to calculate the total volt amps or VA using the volt per square foot table. As an example, if you have a 2100 square foot home and the table specifies 3 volt amps per square foot, you would multiply 2100 square feet by 3 volt amps per square foot, which equals 6300 volt amps. Secondly, calculate the general lighting load in amps. To do this, you divide the total volt amps by the voltage of the circuit. In this case, you divide 6300 volt amps by 120 volts, which equals 52.5 amps. It is important to use 120 volts for general lighting circuits unless otherwise specified. Thirdly, determine the number of circuit breakers needed. To do this, you divide the general lighting load in amps by the circuit breaker rating. For example, if you are using 15 amp circuit breakers, you would divide 52.5 amps by 15 amps, which equals 3.5. You then round up to the nearest whole number, which in this case is 4. Therefore, you would need 4 circuit breakers. Please remember that the general lighting load calculation does not include receptacles. The number of receptacles permitted on a 20 amp circuit is typically 8 to 10, but always consult your local electrical codes for specific requirements. Receptacles are typically wired in parallel to ensure that each receptacle receives power independently. This allows one receptacle to be used without affecting the others. The voltage used for general lighting calculations is typically 120 volts, unless specified otherwise. The circuit breaker rating should be based on the ampacity of the wiring used for the circuit. It is always best to consult the latest edition of the National Electrical Code, or NEC, for specific requirements and guidelines. In the example provided, you correctly calculated the total volt amps for a 2100 square foot home at 3 volt amps per square foot, resulting in 6300 volt amps. You then divided this by 120 volts to get 52.5 amps, which represents the general lighting load. Based on this calculation, you would determine the number of 15 amp circuit breakers needed by dividing 52.5 amps by 15 amps, resulting in 3.5, which you round up to 4 circuit breakers. This calculation specifically addresses the general lighting load and does not include receptacles. The NEC provides guidelines on the number of receptacles permitted on a circuit based on the amperage of the circuit and the load served. For example, NEC section 210.21 B3 specifies that for a 20 amp branch circuit, the permissible load is based on the rating of the receptacles. For a 15 amp receptacle on a 20 amp circuit, the load should not exceed the rating of the receptacle. The NEC does not explicitly state a generic number of 15 amp receptacles permitted on a 20 amp circuit. Instead, it focuses on the total load connected to the circuit. A common practice is to limit the number of receptacles to 8 to 10 on a 20 amp circuit to ensure that the total load does not exceed 80% of the circuit's capacity as recommended by the NEC. This helps prevent overloading the circuit and tripping the breaker. Receptacles are wired in parallel to ensure that each receptacle receives the full voltage of the circuit. Wiring them in series would result in the voltage being divided among the receptacles, which is not practical. Parallel wiring ensures that if one receptacle fails or is in use, the others continue to function normally. To further clarify, let's delve into some additional details regarding electrical calculations and the NEC. When calculating the general lighting load for a dwelling, the NEC provides specific requirements based on the square footage of the building. The volt-ampere per square foot values are outlined in NEC section 220.12. These values are minimum requirements and may need to be increased based on the specific occupancy and usage of the building. For example, a dwelling unit typically uses 3 volt amps per square foot, while an office building may require a higher value. After calculating the total volt amps, you divide by the voltage to determine the current in amps. It's crucial to use the correct voltage for the circuit. In residential settings, 120 volts is typically used for lighting and small appliance circuits, while 240 volts is used for larger appliances like electric ranges and dryers. In commercial settings, 277 volts is often used for lighting circuits, and 480 volts is used for large equipment. The circuit breaker rating is determined by the ampacity of the conductors used in the circuit. The NEC provides tables, such as NEC Table 310.15, V16, that specify the allowable ampacities of conductors based on their size and insulation type. For example, a 14 American wire gauge or OG copper conductor with THHN insulation is typically rated for 15 amps, while a 12 AWG copper conductor with THHN insulation is typically rated for 20 amps. It's important to select the correct size conductor and circuit breaker to prevent overheating and potential fire hazards. The NEC also provides requirements for receptacle spacing in dwelling units. NEC Section 210.52 states that receptacles must be installed so that no point along the full line in any wall space is more than 6 feet, or 1.8 meters, measured horizontally from an outlet in that space. This ensures that occupants have easy access to receptacles for plugging in lamps and other appliances. When wiring receptacles, it's essential to follow the NEC guidelines for grounding and polarity. The grounding conductor must be connected to the grounding terminal of the receptacle to provide a path for fault current to return to the source, which helps protect against electrical shock. The neutral conductor must be connected to the neutral terminal of the receptacle, and the hot conductor must be connected to the hot terminal. Incorrect wiring can create a shock hazard and damage equipment. The NEC also addresses the use of ground fault circuit interrupters, or GFCIs, in certain locations. NEC Section 210.8 requires GFCI protection for receptacles in bathrooms, kitchens, garages, and outdoor locations. GFCIs are designed to detect small imbalances in current and quickly trip the circuit to prevent electrical shock. They are an important safety feature in areas where moisture is present. Additionally, arc fault circuit interrupters, or FSIs, are required in many locations to protect against arc faults, which can cause fires. FSIs detect abnormal electrical arcs and trip the circuit to prevent a fire from starting. They are particularly important in bedrooms and other areas where people may be sleeping. The NEC is updated every 3 years to reflect changes in technology and best practices. It's important to stay up to date in the latest edition of the NEC to ensure that your electrical work is safe and compliant. Many jurisdictions adopt the NEC as their electrical code, while others may modify it to suit their local needs. Always check with your local electrical inspector to determine the specific requirements in your area. In summary, calculating the general lighting load and determining the number of circuit breakers involves several steps, including calculating the total volt amps, dividing by the voltage to determine the current, and selecting the appropriate circuit breaker rating based on the ampacity of the conductors. The NEC provides detailed guidelines for receptacle spacing, wiring, grounding, and the use of GFCIs and FSIs. Staying up to date on the latest edition of the NEC is crucial for ensuring electrical safety and compliance. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical work. Electrical work can be dangerous if not performed correctly, so it's important to take the necessary precautions to protect yourself and others. Furthermore, when considering specific applications, remember the NEC provides additional guidance. For example, when dealing with multi-family dwellings, NEC 220.84 allows for optional calculations for determining feeder and service loads, which can sometimes result in lower overall load calculations compared to using the standard method. This is because it takes into account the diversity of loads in multiple dwelling units. Similarly, for restaurants and other commercial kitchens, NEC Article 220 provides specific guidelines for calculating the load of cooking equipment, which often have higher demand factors than general lighting or receptacle loads. These demand factors allow for a reduction in the calculated load based on the likelihood that not all equipment will be operating at full capacity simultaneously. When sizing conductors and overcurrent protection for motors, NEC Article 430 provides detailed requirements. The full load current of the motor must be determined from NEC tables or the motor nameplate, and the conductor ampacity must be at least 125% of the motor's full load current. The overcurrent protection must also be sized appropriately to protect the motor and conductors from overloads and short circuits. The type of motor and its application will also influence the specific requirements. For example, motors used for air conditioning and refrigeration equipment have different requirements than motors used for general purpose applications. When dealing with transformers, NEC Article 450 provides requirements for their installation and protection. Transformers must be protected from overcurrent on both the primary and secondary sides, and the overcurrent protection must be sized appropriately based on the transformer's kVA rating and voltage. The NEC also specifies requirements for transformer grounding and ventilation. Additionally, when working with low-voltage lighting systems, such as those used for landscape lighting or accent lighting, NEC Article 411 provides specific requirements. These systems typically operate at 12 volts or 24 volts and require the use of low-voltage transformers and wiring methods. The NEC also addresses the use of submersible lighting fixtures in swimming pools and fountains, which have strict requirements for grounding and bonding to ensure safety. It's important to remember that the NEC is a comprehensive document that covers a wide range of electrical installations. It's not possible to memorize every requirement, so it's essential to have a copy of the NEC readily available for reference. When in doubt, consult with a qualified electrician or electrical inspector to ensure that your work is safe and compliant. Moreover, keep in mind that electrical codes and regulations may vary depending on your location. Local jurisdictions may have amendments or additions to the NEC to address specific local conditions or concerns. Always check with your local authorities to determine the applicable electrical codes in your area. This will help you avoid costly mistakes and ensure that your electrical installations meet the required safety standards. Electrical safety is paramount, and compliance with the NEC and local codes is essential for protecting people and property from electrical hazards. Take the time to learn the relevant codes and regulations, and always prioritize safety when working with electricity. By following these guidelines and consulting with qualified professionals when needed, you can ensure that your electrical installations are safe, reliable, and compliant. Firstly, always disconnect the power before working on any electrical circuit. Secondly, use properly insulated tools and equipment. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on live circuits unless absolutely necessary, and then only with extreme caution. Fifthly, double-check all connections to ensure they are tight and secure. Sixthly, properly label all circuits and panels. Seventhly, test all circuits after completing the work to ensure they are functioning correctly. Eighthly, never overload circuits or extension cords. Ninthly, be aware of the potential hazards of electricity and take steps to mitigate them. Tenthly, if you are not comfortable working with electricity, hire a qualified electrician.